the next lecture is by our host, actually, the organizer, Amit Kahana and Doron Lancet. And the title of Amit's talk will be Micellar Self-Organization through Dynamic Compositional Attractors. Life is probable. Please.
Okay, thank you, Gonen, and thank you to all who are attending this year's ILASOL conference. I'm Amit, I am a student of Doron Lancet at the Weizmann Institute, and I'll be talking to you today about attractors and why they are important in the origin of life research. So when we're researching the origin of life, we're taking a systems chemistry approach, specifically from a lipid world scenario view. Very shortly, we think that in the prebiotic ocean, there existed many types of micelles, which are assemblies of amphiphytic molecules of many different types, and that some micelles may have specific compositions that they have attained through mutually interactive and mutually catalytic interactions between their constituents, whereupon they can grow and split while still retaining their compositions, which pertains to homeostatic growth and compositional reproduction. After these few generations of such cycles, we can envision how through compositional mutations, they could undergo evolution and to evolve to something more similar to vesicular protocells that are more traditionally invoked in the field. If you want to know more about this process, you can read our papers or wait for our new paper that will be published very soon in Nature Reviews Chemistry. What I want to focus about today is the notion of homeostatic growth, is where the micelle has a specific composition that is retained over time, no matter if there are more lipids that come in through accretion or through catalyzed synthesis. And we are studying these dynamics by using the GOD model, which is a very rigorous kinetic formalisms we've developed in the lab over the years that is highly founded in nature-like parameters. And we are following the growth and split of different micellar assemblies. And we seem to find that that they relatively fast reach these certain compositions that enable reproduction, where the composition stays relatively stable over time. And we term this a composome state. Now, as I said, even though the composition is very, very rare in compositional space, what are the chances that we will just find it just by random walk? But still, the GOD simulations tend to reach them very, very fast. And this was bothering us for a while, and we have made some new analysis, and we have formally proved that these composome states are actual dynamic attractors in compositional space. Now, what are dynamic attractors and why they're important? So dynamic attractors are just sections in the dimensional space towards a system tends to progress or evolve. And it doesn't even matter where the system starts from. You can start from different initial conditions, and they will all fill the pool and will over time tend to coalesce into this attractor, into the basin of attraction. And once a system is in the basin of attractions, it is less sensitive to different perturbations in compositions. So whether new lipids join the assembly or through split, there are some mutations that happen, they will still remain well within the basin of attraction. And so we wanted to ask, are composomes dynamic attractors? And for that, we've made some new analysis. This is just one example. And I want you to get a feel of this force of attraction. What you see here is a phase diagram that people in different fields, physics, math, chemistry, biology, use to portray attraction. And the different colors are just different simulation runs that we have made through our GOD simulations. Now, I have two axes here that they both portray similarity. the y-axis portrays similarity between the current composition of the assembly and its flux to where the system tends to move temporarily. And the similarity that is shown here is almost equivalent to the temporal capacity for a production. Whilst the x-axis is the similarity of the specific composition to the composition of the compotype, the specific composition that is a composome enabling reproduction, which is more equivalent to long-term reproduction capacity. And you can see how the system starts from different initial compositions. They tour the compositional space for a while. They are sampling different compositions. But after a while, they tend to rapidly being drawn into the top right corner, which is our composome state, where we have long-term and temporal reproduction capacities. And even when it is well within the basin of attraction, still there are some variations in the composition. You can see it's not static, and yet it still remains there, which is a definition of an attractor. Now, we've made a few more analyses that I don't really have time to delve in at this point, but if you have any more questions, you can send them to me. And I just want to leave you with a few take-home messages. So the first thing is that we've proved that mixed micelles that are capable of self-reproduction are dynamic attractors in compositional space. We also illustrate how this attraction can help us mitigate the huge environmental molecular diversity in a prebiotic space, where there were a lot of different molecules that were interacting with different concentrations. And that this attraction actually stems from the mutually catalytic interactions between the molecules in the assembly. Now, the next point is that even while reaching the attractor, there's still a lot of room for different compositional variation and even optimization, which can facilitate the necessary requirements for natural selection and further evolution to a more traditional protocells. And the last point, and perhaps it is the most important one in my eyes, is that the notion of attractors is hugely important to the origin of life field, because when we are trying to search for the molecular components that were responsible for the origin of life, we look at very specific molecules, a very small sample size of the huge compositional and molecular combinatorics that we can manage. And by understanding the notion of attraction, it can both help us understand how life came to be and make it much more plausible, but also help us find the origin of life, because we don't need specific molecules. We need the dynamics of the system to which the dynamical system wants to progress. So that can really assist us in further exploration of this field. So I want to thank you all again for coming and for listening. I want to thank my mentor, Doron Lancet, and if you have any questions, I'm here to answer them.
Thank you, Amit. It was very nice. I think we have time for one question, so I'll read the first one, which I think relates somehow to your summary. So Shashi Thutupali is asking, it was not clear what your initial conditions were. How close are you to steady state compositional state? And is it that the only attractor is that the only attractor in your system?
So the initial conditions are just starting from random compositions of the different counts of the different lipids in their environment and see where the system progressed to. And composomes are actually composition in steady state, because compositional homeostasis means that the relative concentration of each of the lipid type in the assembly stays the same or relatively the same over time period. So this is actually the reproduction prone compositions are the steady state compositions that allow reproduction. Yes.
But there was a second half, which is that the question was whether there is more than one. The answer is yes.
Sometimes there are, yeah, exactly.
So one more quick question. If you answer in one sentence, what goes into the composome? just the component of the micelle or also the exact geometry? Doesn't the composome depend strongly on the environment?
It does. It depends on the repertoire of lipids that we have in the environment, and each lipid has its own catalytic prowess and specific chemistry that facilitates specific interactions. And so we will get different results if we take different set of lipids into the system, of course.
Okay, I guess this is a question for further discussion, and there is another question also in the chat, so please, Amit, answer them
in
writing. Thank you very much.